When most of us picture a cave, we think of a void, a dark, tight pocket of dead rock where biology goes to die, or at least struggles to survive. But hidden in the remote mountains of Vietnam is a massive disruption to that rule. This is Sơn Đoòng, a cavern so completely isolated that humanity had no idea it existed until 2009. To understand why this place stayed hidden, you have to look at the raw math mapped out in its dimensions. This cave stretches for 9 kilometers and holds 38.5 million cubic meters of empty space. The main passages are so enormous, you could drop an entire 40-story skyscraper straight inside. The horizontal clearance is equally massive. There is enough space near the ceiling of this chamber to fly a double-decker commercial airliner straight through. Deep within the silence of this void, explorers discovered something impossible: thick, swirling clouds and an untouched prehistoric rainforest trapped hundreds of meters below the surface. So how does that happen? What exact mechanical and geological systems allow a sealed void, completely starved of sunlight, to operate like a living, breathing planet? It starts 450 million years ago, long before dinosaurs existed. The bedrock here is a calcium-rich limestone, built entirely from the crushed remains of ancient sea life. Over millions of years, layers of shells and marine skeletons sank to the ocean floor and compressed into incredibly dense stone. You can actually see the evidence of this in the cave wall today. This is the circular, ribbed structure of a tetracorolla, an extinct marine coral that died out 300 million years ago, perfectly locked inside the rock. But solid stone doesn't just hollow itself out. The process started when massive tectonic shifts cracked this limestone foundation, opening deep fault lines right through the rock. Those fractures gave water a way in. Rainwater is naturally slightly acidic, and since calcium dissolves easily in acid, the water slowly ate away at the rock. Over 3 million years, this constant chemical erosion widened those tiny cracks into massive underground canyons. The minerals left behind by that dripping water piled up, creating enormous internal structures. In the largest section of the cave, there is an 80-meter-tall stalagmite that took an average of 800,000 years of continuous dripping to reach its current size. Combine immense spans of time, relentless pressure, and acidic erosion, and you get a structurally sound, skyscraper-sized container, perfectly primed to host life. A container this massive needs a power source to support an ecosystem. Heavy rains feed incredibly fast underground rivers that carve through the cave floor, constantly dragging in mud, seeds, and organic matter from the outside world. And because the cavern has so much internal volume, it creates a stark thermal difference. When warm surface air flows down, it violently collides with cooler subterranean air. This sudden drop in temperature forces moisture to rapidly condense, resulting in distinct cloud formations and thick mist trapped beneath the rock ceiling. This means Sơn Đoòng doesn't rely entirely on water flowing in from outside. It has its own internal atmospheric engine, providing a continuous moisture cycle that acts as the lifeblood for a terrestrial ecosystem. Down in the permanent dark zones of the cave, life has adapted to strict deprivation. You'll find completely eyeless fish and blind crickets, and cave worms that produce a glowing blue-green light from their tails to attract and trap flying insects in sticky threads. But the biology radically changes where the architecture failed. At 2 distinct points, the river flowing inside the cave weakened the massive limestone ceiling, causing it to collapse. These giant holes, called dallines, broke open to the sky and allowed massive columns of sunlight to pierce the darkness. That sunlight met a floor primed for growth. Millions of years of bat guano had piled up, creating a deep, highly fertile layer of soil. When floods washed in plant spores and seeds, an entire jungle took root. But growing in a cave forces botanical extremes. Because they only receive light directly from the skylight above, these trees don't spread out. They prioritize height, growing precariously thin and shooting up to 50 meters tall just to absorb the sun. The environment is so robust that surface-dwelling primates have actually moved in. Monkeys, like the red-shanked Duke langur, travel deep into the cave's jungle, making this a rare subterranean environment capable of supporting complex mammal life. Extreme deprivation of light in the depths, paired with extreme bursts of it under the dollines, forces biology to adapt fast. It creates two entirely distinct ecosystems operating side by side in the exact same cavern. Sơn Đoòng is a biological paradox. It is simultaneously a fossilized graveyard holding the 300-million-year-old remains of dead oceans and an active laboratory where biologists have recently discovered 7 entirely new animal species found nowhere else on the planet. The line between geology and biology even starts to blur. Deep inside, you can find rare phytokarst formations. These are limestone structures fused with algae and mosses that actually physically move and lean toward the sunlight, like semi-living rocks. But this closed-loop system is highly sensitive. An ecosystem built slowly over 400 million years is uniquely vulnerable to the slightest shifts in surface climates or human interference. Sơn Đoòng revealed how life adapts to total isolation. It shows that biology doesn't merely tolerate a hostile environment, it will hijack the rock itself to create a foothold. Given enough time, a steady flow of water, and just a tiny fraction of sunlight, the darkest, deepest abyss on Earth can build a thriving jungle, and it leaves you wondering exactly what else is currently hiding in the dark.